to quickly introduce myself, my name is Sai Vennam. I'm a developer advocate and an offering manager at IBM. And I also create YouTube videos around Kubernetes, cloud native, and cloud computing concepts. So I'm really excited to be here in Seoul today. In fact, I was so excited that I actually came a full week ago, and I spent this time exploring the city, trying all the local food. I think my favorite thing so far is tteokbokki. Hopefully I'm saying that right, but best thing I've had. I think I could live off of that. But here today, I'm here to talk about multi-cluster and multi-cluster strategies to Kubernetify applications. Yes, that's the word that I made up. I like to start with a number, 93%. Now that's a pretty big number. These are the number of companies out there using multiple infrastructure clouds. It's pretty big. Now, 81%, now according to an IDC analyst survey of multi-cloud management, that's 81% are using multiple public clouds and one or more private or dedicated clouds. Now, the key takeaway from this is that companies want to avoid vendor lock-in. They're essentially taking solutions and running applications in a way that doesn't lock them into a single vendor, but instead allows them to take advantage of multiple clouds. But so far, we've really only talked about why multi-cloud and the prevalence of multi-cloud. Let's break down multi-cluster and why exactly you need to start thinking about that. So the simple one is DevOps, right? So your developer starts creating a cluster, maybe you need to test that in another cluster, and finally you run that in production. All of that is going to lead to its own individual clusters. Now let's take that a step further. Say you want to run this in multiple regions, not just US South, but you also want to run it maybe in Seoul and Sydney. For two reasons here. You want to be kind of localized to where your end users are, and two, for high availability. So if one of the clusters happens to go down, the other prod cluster picks it up. Now that's two reasons for why you'd want to do multi-cluster. Now the last one is one that we already talked about. The future is really multi-cloud, not just single cloud development. Companies want to avoid vendor lock-in. So when you start thinking about deploying these across multiple cloud environments or in cloud environments where it makes most sense to run them, you start to see the problem. So many different clusters that you need to start reining in. Let's break it down with a kind of a simple example. Kubernetes solved this on a smaller scale, right? So Kubernetes allows an operator to schedule out an application across multiple worker nodes without ever having to worry about those individual nodes. It just says, hey, I want an application, and the Kubernetes takes care of the rest. Now, on a similar scale, what happens when you start having multiple clusters? Let's say you have 4. It's starting to look really familiar, right? We need another abstraction layer. Something that Kubernetes Master does for compute and virtual machines or whatever it might be, we need another similar type of abstraction layer to rein these in. Now, you might want to start with something simple like visibility. Visibility is going to allow you to see what Kubernetes resources are running where. Maybe what version is running in each cluster, what pods are running where. Maybe things go down. You want to be notified of that right away. Next, you probably think, hey, I need not just the ability to see things, but also deploy things, automate it out, federate it. So say you want a consistent network policy across all of your clusters. At that layer, you start to get the same thing that the Kubernetes master does in a single cluster. You start to have the need for a federation API server. Now, there's one more problem when you start having multi-cluster, and this is going to be service-to-service communication. So that's kind of different. It's not the same layer as what we talked about with the federation API. It's kind of at a different layer, the service mesh layer. So when applications are talking to one another, say one application in North American cluster is dependent on one in Asia Pacific, that's going to be a different problem to solve, something that's solved by service mesh. Regardless, all of these problems are something that are solved by having a control plane. At the end of the day, when you want to start thinking about your multi-cluster strategy, you need to identify what that control plane is going to be. So today, my goal is to talk about some of the open source solutions out there today and some of the multi-cluster strategies that are being worked on in the community right now and are potentially solutions for you as an enterprise or a company or a consumer to start thinking about your multi-cluster strategy. The first one I want to mention is KubeFed, and I've actually saw that a couple other talks today mentioned KubeFed as well. It's gone through a couple of iterations. It started off as Kubernetes, and then KubeFed version 1, which then got deprecated. Now it's on version 2. Now, KubeFed is sponsored by a Kubernetes special interest group, the CNCF. It's actually called SIG Multicluster. And I'd say the best way, if you want a community-driven solution to do multi-cluster, the best way to get that is to get involved, join the Slack channel, Google SIG Multicluster, and they actually have a survey out right now to understand what the requirements are from consumers. So get involved and see if they're kind of heading the right direction with this capability. They're rapidly approaching a beta, even though they are currently in alpha. Next, I want to talk about RASI. So in production, IBM Cloud actually runs close to 20,000 production clusters. Now, along the way, we picked up on a lot of different things that we needed to do to make that run smoothly. Now, a bunch of those clusters we're running for our own services, but our consumers are kind of running clusters on our cloud as well. So along the way, we realized we need a tool to get visibility into those clusters and then actually start administering them, deploying new versions, maybe updating the clusters, and that kind of thing. So recently, it was actually at KubeCon Barcelona, we announced RASI, which is a multi-cluster continuous delivery tool for Kubernetes. And you can get started with it today by going to rasi.io. It's still in the kind of early phase, but it's very doable. We've got great kind of documentation on it and allows you to get started with automating some of these multi-cluster requirements. Now, the last one I want to mention here is Istio. Istio is a service mesh. This is going to solve that service-to-service level communication. Didn't know Istio was actually a project jointly created by Google, Lyft, and IBM. Back then, Lyft had Envoy. They still do, which is still being used. IBM had Amalgamate, and then Google contributed the service control plane. Those three came together to solve and create Istio. Now, Istio is essentially a service mesh that allows you to do just those 4 things that you see here: connect, secure, control, and observe services. Essentially, the way it does this is by injecting a pod, or a container, into every pod in your application architecture. It then intercepts all network traffic. Now, that's a very crucial place to be. It allows Istio to automatically, without having to instrument with any code, do a lot of really interesting things. Let's give an example. Let's say a new engineer joins your team and wants to learn about your application architecture. So the first thing you might do is sit them down and say, hey, this is all the microservices we have, and this service talks to that one talks to this one. You kind of start sketching things out. Well, with Istio, you can get that service mesh drawn automatically. And the reason it's able to do that is through that pod injection that I just talked about. It's able to do these kind of things. Now, that's just a small portion of what Istio can do, but kind of demonstrates the power. So far, Istio has seen great production and evaluation. A lot of companies out there are evaluating it for service mesh, but usually it's within a single cluster. But companies want more than that. They want the ability to do service mesh across multiple clusters. Istio knows that, and from the beginning, they've been creating capabilities to allow you to do that, patterns to do multi-cluster with Istio. So in the latest version of Istio, there are some experimental capabilities, and I want to walk through that now. So today, with kubectl config, you can add multiple contexts. You can be connected to multiple clusters. That's kind of what we see here. So I'm connected up to 3 clusters, 2 in the east network, 1 in the west network. The 2 in the east share the same network. Next, I create a topology YAML. This is really simple. Essentially, it just tells me, or it tells Istio what clusters I want to join, and then it tells it what networks they're in, whether they're in the same network or a separate one. And finally, once you have Istio installed in all those clusters, you run this experimental command, istioctl x multicluster apply, and it does all the heavy lifting to mesh those clusters together and essentially allows services to talk to one another. Now, a good example for this is, let's say one of the services in one of the cluster stops accepting traffic, just crashes. Istio set up the ingress and egress policies so that it can fail over to the similar version of that app running in an entirely separate cluster. It's one of the things that makes Istio so powerful, especially when you start adding multi-cluster. Now, coming back to that architecture diagram we have and the 3 things we talked about, KubeFed hits that federation API server layer, allowing you to automate Kubernetes resources. RASI focuses on visibility and continuous delivery of those Kubernetes resources. And it does some of the same things that kubefed does. And finally, we've got Istio to solve that service mesh layer, that communication between services that allow you to do some of those capabilities that we talked about. Now, it's very important to start thinking about your multi-cluster strategy today. If you're using Kubernetes successfully, chances are you're going to need more and more Kubernetes clusters as you mature. With a unified control plane, you can gain visibility into what's running where. You can automate the deployment of Kubernetes resources across multiple clusters. And finally, you can manage network traffic between microservices and add additional security, things like mutual TLS and that kind of thing. That's all the time that I have today. If you're interested in learning about more of these concepts, check out the IBM Cloud YouTube, where I've uploaded a number of videos. And I want to thank you again so much for having me here in Seoul.